All right, starting my recording again so that we actually are going to get this recorded. So first one, s plus 1, quantity squared plus 1. Second one, s plus 3, quantity squared plus 16. Everybody should be good on both of those? All good? Okay, let's try this to do some functions with actual differential equations. Here's the translation that you need for today. And it's going to look a little bit goofy, but that's okay. So today's translation is the Laplace transform of e to the a t times f of t is equal to capital F of s minus a. I'm looking to see if this is in the front of your book stated generally like this. Is it? It is. So this is the 1, 2, 3, 4, 5, 6th line down, 7th line down in the front of your book. This is the 7th line down in the front of your book. That's what I'm looking at. What helps is the reverse direction. Inverse Laplace transform of capital F of s minus a is e to the at times little f of t. So the inverse one is the one that we're going to use today. There is a proof for why this works in my notes using the definition of the Laplace transform. So I won't make you do it, not going to make you go through and walk, but if you want to, you can see why this works using the definition of the Laplace transform. Here's the place where it's easy to get slightly confused. I have to have an s minus a, and a is going to be a number, in every single place where there's a variable in my transform that I'm working with. And this will come out when I do the first example. So I have to have an s minus a, and remember that a is just a number, can either be positive or negative, either way, but I have to have an s minus a in every single place I have a variable in my transform. So I can't just have s's, I always have to have an s minus a. Promise that'll make more sense when I do this next example. So let's go to next example here. For example, we have differential equation x double prime plus 6x prime plus 25x equals 0. X naught is 2 and x naught prime is 3. X double prime plus 6x prime plus 25x equals 0. X naught is 2 and x naught prime is 3. Here's what I want you to do on your own for just a second, steps 1 and 2. So take the Laplace transform of both sides and then solve for capital X of s. So do steps 1 and 2 for me on your own, please. X double prime plus 6x prime plus 25x equals 0. X naught is 2, x naught prime is 3. Do steps 1 and 2 on your own. Steps 1 and 2 on your own. You can check your answer when you're done if you want with my whiteboard. So I get 2s plus 15 over s squared plus 6x plus 25. Are we good with that? 2s plus 15 over s squared plus 6s plus 25. Give me a thumbs up. We're good to go. Okay. All right, this denominator does not show up anywhere in the front table. So this is where we're gonna need to use completing the square. So we just did this one. We can do 2s plus 15 over s plus 3 quantity squared plus 16. That was our previous completing the square example. We just did this. Here's the part where you have to be careful. In the denominator, what I have is an s plus 3 quantity squared. So therefore, I can't just have an s in the numerator. It has to also be an s plus 3. So we're going to need to do a little bit of algebra, a little bit of rearranging. I can't just have this s in the top. It needs to be turned into an s plus 3. So let's go ahead and do that. 2 times s plus 3 plus 15. My denominator is wrong. I'm going to need to fix that in just a minute. Our numerator, s plus 3 squared plus 16. So I need to turn that s into an s plus 3 in the numerator. I have to do 2 times s plus 3 plus 15. I can't just have a plain old s up there. And then in order to fix that, I really just added 6, right? So I need to subtract 6 back off. So I'm going to need to subtract 6 back off. And that will give me a plus 9 for the constants in the numerator. Okay, so far so good. All right, ready for an inverse transform here. So let's split this into 2 pieces. This is kind of what we were doing yesterday. We'll split this into 2 pieces and find the inverse transform of both. So we've got a 2s plus 3 over s plus 3 quantity squared plus 16 plus 9 over s plus 3 quantity squared plus 16. 2 times s plus 3 over s plus 3 squared plus 16 plus 9 over s plus 3 quantity squared plus 16. Okay, here's what I want you to do. In this first one, if I just had s's, if I did not have s plus 3s, if I just had s's, figure out what your little f of t would be. If I just had s's and not s plus 3s. Take a look at the front of your book. What would your little f of t be if I just had s's and not s plus 3s? If you got it and you feel like volunteering, raise your hand. If I just had s's and didn't have s plus 3s, and you got to raise your hand virtually. Can't see you right now. If I just had s's and not s plus 3s. Stuart, what do you got?
Cosine 4t.
Yep,
2 cosine 4t.
Yep, there's a 2 in the numerator, so 2 cosine of 4t. Okay, here's the rule that we're operating under in this particular example. The inverse Laplace transform of capital F of s minus a is e to the at times little f of t. So I identified my little f of t, that's 2 cosine of 4t. The other thing I need to figure out is what my a is. So I'm supposed to be having f of s minus a, and therefore my a is -3. S plus 3 is the same thing as s minus -3, so that's my a. Okay, a is equal to -3. So the inverse transform of this first one is e to the -3t times 2 cosine of 4t. You see where that's coming from? Putting those 2 pieces back together. The 2 cosine of 4t is what I would have without the s plus 3, and the s plus 3 gives me an e to the -3t out in front. That's the first part. We still got to do the second part. Okay? Second part here. Think about for your second part, what would your little f of t be? And you're going to need to do a little bit of messing around with the number on the top. So if you didn't have an s plus 3, what would your little f of t be? Front chart of your book, you're going to need to mess around with the number on the top just a little bit. Do a virtual hand raise when you think you got it. Stuart, you answered the last one. Somebody else can answer this one, but thank you. Somebody else have this one when you got it? Be brave, raise your hand virtually. Otherwise, I'm just talking at a computer screen and that's no fun. Even if you don't have the coefficient on the top quite right, you can still be brave. What do we got? Somebody help me out. Oh, people. Stuart, you raised your hand before. Somebody besides Stuart totally needs to answer this one. Zach, what do you got?
4/9 sine of 4t.
I like that. 4/9. It's upside down. You want 9/4 instead of 4/9 because you want 4 on the top. So we need to say 4 times 9/4. So 9/4 instead of 4/9. But other than that, you are totally right on. So we are going to have a 9/4 sine of 4t. So therefore, a is also equal to -3 in this case, and the inverse transform of this one is e to the -3t times 9/4 sine of 4t. You could pull the e to the -3t out of both pieces if you wanted to. You wouldn't have to, but you could. Again, the trickiest part of these, I'm going to go back one slide. The trickiest part of these is remembering that you have to have an S minus A every single place you see an S. So I can't just have an S in the numerator. I got to make that into an S minus A, which is S plus 3 in this case. Okay. I'm going to make you big enough so I can see all of you, and then we're going to try another one. Any questions so far? How we doing on that one? Give me a thumbs up, thumbs down. How we doing on that one? Making sense? Yes, good. I'm getting some thumbs up. Okay. All right. Let's try another one. And this one's going to not start with a differential equation. I'm just going to tell you something to find the Laplace transform of. So we're kind of jumping into, we've done step 1, we've done step 2. So for example, capital F of S is equal to this, S squared plus 3 over S squared plus 2S plus 2 quantity squared. S squared plus 3 over S squared plus 2S plus 2 quantity squared, and I want to find little f of t. Actually, I'm going to label these as x's, I think. So let's say this is capital X of S, and we want to find little x of t. Doesn't matter what you call it, but I've been calling it x for a while. So let's go with capital X of S and find little x of t. Okay, so I'm going to need to complete the square in the denominator. We can do that. We did this. This is the other completing the square example. So we've got S squared plus 3 quantity squared over S plus 1 quantity squared plus 1. And then all of that is squared. So we did the completing the square example already. That's what I'm going to end up with in the denominator. S plus 1 quantity squared plus 1, and then all of that is squared. This is something, and you're going to make huge faces at me, and that's okay. This one is where you also need partial fractions because I've got a repeated quadratic factor in the denominator. So I need partial fractions. When you have a repeated factor, remember this looks like the factor. So that's my first denominator. Factor is going to be S plus 1 quantity squared. That's my first denominator. And then my second denominator is that part squared. So S plus 1 quantity squared plus 1 quantity squared. Those are my two pieces. The basic factor I am working with is the S plus 1 squared plus 1. That's quadratic. So the basic factor on the top is going to be AS plus B and CS plus D, partial fractions. Basic factor on the bottom is quadratic, S plus 1 squared plus 1. Basic factor on the numerator then is then AS plus B and CS plus D. Partial fractions are in my notes. You can walk through and figure out what those are. And let's make sure I have my A, B, C, and D in the right place. This time I do. A is 0, B is 1, C is -2, and D is 1. Those are my answers that I get if you do partial fractions. A is 0, B is 1, C is -2, and D is 1. So let's put this back together into partial fractions, and then we'll see what we have. x of s is, I'm just going to skip the a because it's 0, 1 over s plus 1 squared plus 1. That's my first piece. Plus negative 2s plus 1 over s plus 1 quantity squared plus 1 quantity squared. 1 over s plus 1 squared plus 1 plus negative 2s plus 1 over s plus 1 quantity squared plus 1, and all of that is squared. There are like 18 squareds in this problem. First piece should not be a huge, horrible thing. I would like, think about what your first piece is for what's your f of t and what's your a value. Look in the front of the book. If you just had an s here instead of an s plus 1, we know that a is going to equal negative 1 because it's s plus 1. If you just had an s here instead of an s plus 1, what would your transform be? If you just had an s instead of an s plus 1, what do you got? Give me a virtual hand raise, front of your book. Help me out. There aren't even any coefficients that you have to play with. Stuart, what do you got?
E to the negative t sine t.
So yep, if I didn't have, I'm breaking it down into 2 steps and you did it all in one. So if I
sorry.
have, that's okay. If I didn't have an s plus 1, it would be just sine of t, right? If I didn't have an s plus 1, it would just be sine of t. And so therefore, this first part is going to be e to the negative t times sine of t. That's my first part since I have a equals negative 1. Okay, second piece here, I have an s in the numerator and I can't have that. The s in the numerator can't stay. It has to match the s plus 1 that I have in the denominator. So I'm going to need to turn the second piece into negative 2s plus 1 plus 1. We're going to have to fix that in just a second, over s plus 1 quantity squared plus 1 quantity squared. I still have to fix the numerator. I totally got to fix the numerator. I can't have an s in the numerator. It has to match what I have in the bottom. So what I just did was, sorry, I am now doubting myself. What I just did was subtract 2. I've got a negative 2 times 1, and so therefore I have to add 2. So I need to finish this out by adding 2. And this one, I'm sorry, this is getting a little messy. This is where I wish I had a regular normal board that I could be working on. I'm going to need to split into 2 pieces. So negative 2 s plus 1 over s plus 1 quantity squared plus 1. Quantity squared, we've got that one, plus 3 over s plus 1 quantity squared plus 1, and all of that is squared. So we've got 2 pieces to be dealing with here. We've got the pieces with the s plus 1 in the numerator and pieces with just the constant in the numerator. Okay, for both of these, a is equal to negative 1. A is still equal to negative 1 for both of these. Look in the front of your book or on your table, and for this one, you're going to need to go to the right-hand column if you're looking in the front of your book. Right-hand column. 1, 2, 3, 4, 5, 6, 7, 8, 9th and 10th lines. Yes, 9th and 10th lines in that right-hand column. Do we see those 9th and 10th lines in that right-hand column? If I just had s's and not s plus 1s, 9th and 10th lines in that column. For each of these, k is equal to 1. I was a little bit nice to you, 9th and 10th lines. That first one is going to have f of t, that is the 10th line. So t over 1 times the sine of t, and then I need a 2 out in front, which is a negative 2. Negative 2t over 1 sine of t. That is the 10th line in the right-hand column in the front of your book. I'm going to view this so I can see all of you guys and get you to give me a thumbs up that you're seeing that. the 10th line in the front of your book, and I might have given you the wrong one. Question. Yeah, Stuart.
Shouldn't it be t over
2K.
2?
2K. Yep. T over 2 times 1. Let's do a little bit of erasing here. T over 2 times 1. Thank you. Yes. So what we have is f of t. We've got a -2. We've got t over 2 times 1. And then we've got sine of t. Yes. Thank you. Okay. Everybody give me a thumbs up. 10th line. We're seeing that one. 10th line in the front of your book. 10th line. Yes, good. Okay. The other one, I want the 9th line. So f of t, I've got a 3 out in front. I've got, oh, this is messy and it's not going to fit here. Let's go down a little bit further. So we'll go down over here. F of t is 3 times 1 over 2 times 1 cubed. And then we've got some messy stuff here. Sine of t minus 1t cosine of t. That's the 9th line. That one's messier. So 3 times 1 over 2 cubed, 1 over 2 times 1 cubed sine of t minus t cosine t. That one's horribly messy. That's icky, and I didn't write this nicely at all here. Are we good on that one? 9th line? Do we see the 9th line? We see the 9th line? Yes. Helping me out? Yes. Okay. So let's finally go back, and each of those need an e to the -t in front of them. So here's my final answer way down at the bottom of the screen, plus e to the -t times -2t over 2 sine of t. You could absolutely do some simplifying and cancel that if you wanted to. You could totally simplify there if you wanted to. Plus e to the -t, here's my mess, 3/2 times sine of t minus t cosine of t. Let me see if I can actually box my answer for little x of t along with the rest of, I'm sorry, this is the yuckiest board work that I've done in quite a while. That's horribly disorganized, and there would be arrows everywhere if I had a regular board for this. Okie dokie. How are you doing on that one? It's messy. It's definitely messy, but if you follow the chart for the front of your book, hopefully it will be a little bit better. Any questions, any things I screwed up, which is entirely possible with all the mess for this one? Zach, yes.
Shouldn't the third piece be 3/8?
Nope, because it's just 2 times 1 cubed. Only the 1 is cubed, not the 2. Good question. But nope, it's just the 1 being cubed. So just 3/2. Yes. Other questions? Okay. Yes, this one's messy, but we're okay. Help me out. Thumbs up. Yes, doing okay. Kind of, sort of. You're going to get more comfortable with this stuff in the front of your book when you play with it a little bit more on homework. But again, thing I want to emphasize for the 850th time is you can't, I'm over on the left part of the screen here, you can't have an S minus A somewhere and just a plain old S somewhere else. You got to have all of your pieces matching. If you have an S minus A somewhere, you got to have an S minus A everywhere. It's really easy to forget. Really, really easy to forget. Okay, I am going to stop sharing my screen so we can do a pause on the recording for just a minute.